start the meeting with company update?
Sure. So we got to think about where this stuff's going to start to get adoption, and we have to think about what the boundary between users and developers is. So the key to making projects, I think, successful is to be able to build something that normal people can understand the value of, but only a sort of self-selected chosen group can understand what it is and why it's valuable. I've been talking a lot about like philosophy with GPT 5.5. So like we have to think about what type of audience we want to target. And there's like the eGPU audience, and that's one audience. And there's like the same audience the tiling targets. Then there's like the PyTorch audience. And yeah, and we just got to think about kind of who our audience is. And I think our audience, I think we try with the eGPU people and LLM, and we try with like the tiling kind of people. And I think it's less going to be the PyTorch kind of people, at least for now.
Okay.
Because we haven't really succeeded at getting conversion from that. So yeah, I mean, we got to think about how to. We win because if we win, it's because our IR is like tiny. It's not because from a user like it's just way too ambitious to try to target the kind of PyTorch people, and I think this was a mistake. But I think the right people to target are the people who are writing either this I just want the LLM to run type people, or the okay, I want to write a kernel and explore high performance on my slightly off the beaten path hardware type people. And I think that's how we target both the kind of like the pipeline to developers and then this sort of user hype people who are like, wait, you actually won't believe the tokens per second I'm getting on my eGPU, blah, 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 blah. Um, yeah, I think that's kind of where things have been going. And then the more boring company update thing, we got a bunch of chestnuts. Got like 20 built. I think they work. They work?
Yeah.
Well, why doesn't my CI work?
Well, hopefully swapping some cables around fixed it.
All right, great.
Who is using Thailand?
Who's what?
Who use Thailand?
Oh, DeepSeek.
Okay.
DeepSeek v4 wrote all their kernels in Thailand. And like, in many ways, we're a better tiling. We just didn't integrate with the high speed NVIDIA stuff.
Okay. Our goal is to integrate those.
No, I don't care about NVIDIA. Let's do it for AMD, right? Yeah, but our goal is basically to be able to. It's the same project, right? Like not much has actually changed. The Llama speed up project is basically the same project, right? Like we want to write a really high performance Llama trainer that outperforms the hipstack one.
Yeah, but if the issue is not using the whatever the fast stuff, are we using the fast AMD hardware features?
We should be able to, yeah. I mean, we are right now. We're using custom kernels. So the custom kernels are pretty bad. The custom kernels, and these are the same ones AMD used. They were only getting like 50% MFU on gems. Yeah, I mean, there's no reason we don't support that, right? Like it's the same way we write this like the Llama kernel, but how do we get the Llama kernel to work on MI350X, and how do we get it to be faster than the AMD one?
I see. Okay.
Yeah, I mean, I think the way to do it is search. I think that the thing that we can get that Tilelang doesn't get is search. Tilelang's IR is kind of. I mean, it's they layered it over TVM. I think they also now have a Qt DSL backend. But you inherit all the problems when you layer on top of those things, which are you're left with this extremely complicated hand-tuned Codegen pipeline that happens to work for really one piece of hardware. And I don't know if it's like I didn't experience the fragility of it, but I didn't stress it that hard. Like with Triton, I would run into all these places where it was just extremely fragile. Like if you do stuff slightly different, you'd lose 10x performance and you'd have no idea really how to debug it. With Tiling, I didn't find that. With Tiling, I found that like it was a lot more robust. So. But then when you look at the Tiling syntax, it's interesting. Like Tiling's an example. It's not a programming language. Triton tries to be a programming language, in the sense of like you can express arbitrary things in it. But when you look at the Tiling example, like on the front page, you can look at that t.copy, right? And this is nonsensical Python. Right, because block M is just defined as an integer. It's not like those things are ranges.
Where should I be looking at?
Well, the thing I just did T copy I just posted. Like, what does that really mean?
Copy.
Oh no, maybe by is a range. Oh no, maybe by is a range. Okay. A little confusing. Yeah, it's not like selecting a it's a range. Okay, that makes sense. But it's not like selecting a like you'd expect the copy to be like a slice. Right? That's taking like a slice out of the global memory and putting it into the shared buffer, and you'd expect it to be a slice.
Okay, I mean, I don't know
Actually,
enough. This looked like it copies the first slice into the shared memory.
yeah, it actually looks like by is a range. Okay, that's actually more sensible than I thought. But yeah, we should look into Tilelang and make sure we can basically express all these same primitives that they can, which we can. ChatGPT says we can, but we just gotta actually do it and figure out how they're getting performance when we aren't.
Interesting. Do you know why they picked Thailand? I think they previously write their kernels. Is it just the new hardware is very hard to use, or I don't even know what hardwares they have access to?
See if they say why. Okay, so this is the library that we should
I see.
and they have a note there. However, they don't represent best practices, and we are actively working on improving the code quality and documentation.
Makes sense.
But yeah, it's interesting. Yeah, that they moved off of.
Because this looks very specialized.
What do you mean?
They said in their tile kernel that the kernels here approaches the limit of hardware performance. So I would imagine it's less robust if you want to copy this to other machine.
Oh, I'm sure it only works for the one GPU. Yeah. But I don't know. I mean, I've read the code looks nice. The code looks quite like readable.
Great.
They're also doing these things called fragments. This is another cool feature of tiling that I haven't really seen before. So Triton doesn't let you talk about the registers. Triton just operates at the local scale and then has the compiler do all of it. Tiling lets you define the registers, and they have this thing called fragments, which is basically multi across the registers. And we have to make sure that our new multi stuff supports what fragments are. A fragment just means like it's a register on each of the warps. Right, you can imagine like when you do like a copy from like a locals to fragments, right? It's like going to the registers in each warp, and it's nice, and you don't have to hand specify how to index the fragment. It's basically multi.
It's also interesting that they have a full transpose kernel.
They have a which?
They have a kernel for just transpose. Make
Oh
sure
yeah.
it's fast. Okay,
Okay.
anyway, I'll read this.
Yeah. No, but it's very it looks like syntactic sugar on top of Tinygrad. Like we can write a lot of the stuff that they have as syntactic sugar. And I mean, I am curious what backend DeepSeek used because this is I mean, is it really based on TVM? I thought TVM was kind of dead.
So everyone under the hood in some version use DVM.
Oh, but like have you seen the commits on TVM? It's a dying project. Oh, maybe there's a little bit.
Or maybe it's a complete project. Who knows?
No, it's definitely not complete. Um, actually, there's been a slight uptick.
Yeah.
Um,
Okay. Anyway, we'll see. We'll see what speed we got for. Oh, I think that's just because person was hired by NVIDIA or something, right? They are not supposed to do any work for the 6 months or something.
wait, who was hired by NVIDIA?
The TPM person or the
Um,
whole TPM team or something like that.
yeah. Oh, I didn't know about that.
Yeah, I think they are required. That's why it went down a bit. Okay, anyway.
Yeah.
Cool. Okay. Sounds like a good segue into Llama.
Yeah, we have a transpose kernel now.
Great.
What's our best time we got now?
Still 254.
54. And
It's very
are
dependent
you
on seed, because some seeds you'll just converge in more steps. So if you get a good seed, you're slightly faster.
I think now we should try to be stabilized and really try to run things like back to back for 5 times and see if all of those converge.
Yes, that's basically what I've been doing. I've been prepping a bunch of stuff for submission. So I went through the MLperf logging package checker, and it passes. So submission, we're good for submission.
Yeah, Chenyu, I think you're the only one who's actually submitted one of these. Could there be anything we're like missing? Could there be anything that's like wrong and it'll get rejected?
I mean, as long as you run it back to back for 5 runs and at least 4 of those converges, I think in principle we are good.
So it's
Then
10 runs.
Oh, I thought you said 5 last time.
Yeah, I was wrong last time. I checked again and it's 10 runs.
Okay, so I think 10 rounds still it needs to be good. I think 8 or 9 of it should converge.
Yeah.
I mean, yeah, let's start doing it. We don't have that many more days.
Yeah, because if it's like 3 hours, then also does how does the setup look like? You also need to. You only have like 30 minutes for setup, right? From scratch.
Yeah.
So it's all the like prepping, searching, whatever data movement processing thing.
We can't do data prepare and setup though, right? Because that's technically touching data.
Uh, yes.
Yeah.
So basically just the search of kernels. If you still have any kernel left search.
Yes, there is.
Okay.
Yeah, so beam happens. Like it's the run-in time still does beam and
Yeah,
then
just make sure the first part is below 13 minutes.
Yeah.
And the logging should reflect that. Yeah, I won't worry too much. After the review, the worst case is they find some minor issue and we probably need to rerun. I don't see any big issue. Especially if it's not very fast and challenges everyone's time.
Yep.
They only pay super attention if they are faster than your fastest, and if you are Google doing very fast time, then NVIDIA would be very unhappy about your result. Other than that, I think it's quite peaceful.
Well, yeah, I mean, we have to make sure that we do everything right this time, because next time we might actually get times that upset people.
Yes.
Yeah. So I think now we know is if 10 times, we need to start doing these back-to-back runs. This is just to make sure like the parameter is good for actually for conversions, because when we test, if it doesn't look good, we will terminate it and run a new one, and we cannot do that for a submission.
Yes. So far I haven't really stopped runs early. They've all converged.
Yeah, that's great. Let's just making sure, say, to start with like 3 to 5 back-to-back ones for the final one. And yeah, if you merge like everything in the master and just config for a small one, or you still have many things left not merged.
For the 254, everything should be merged.
Okay, sounds good.
Yeah, let's just unless we see a magic way to get some time speed up, let's stick with like what's in master and what we trust. If we get a 254, we get a 254.
Yeah.
Is it logging merge?
Yeah, logging's merged.
Okay. Okay, then let's just do some runs. Once you feel comfortable that there's nothing magically you can make it faster, start to do the like 10 rounds back to back.
Yeah.
Be able to submit sometime this week. So previously I always wait until the last 2 days because that's when we have a result. But if we are ready and we want to be extra careful, once you have the thing ready, we can have the submission. We can have submitted.
It's also possible. I'm looking more into speed this week, so if I find something, I will push submission until next week.
Well, I mean, let's get it ready so we have something to submit at this speed, and then if we get a speed up, we get a speed up.
Okay.
Yeah, like just spend a day or two, have 10 rounds ready for submission, then we can submit it. And if between our first submission to the deadline you find something, that's we can resubmit.
What's the latest with AMD fixing the other computer?
So far, I sent them pictures that they asked for, and then they haven't responded. I'm assuming they also haven't contacted you either.
No. All right, I'll send an email following up.
Okay.
I mean, this actually makes it impossible for the 405B things.
Okay, sounds good. Let's get a submission candidate and just submit it and get it done.
Yeah, and then just to think a little bit beyond. Once we get this submitted, I want to start. Can we do a 405B? Is there any reason we can't?
We should be able to. I need to see if There might be some memory issues.
Yeah, I mean, it
Something
doesn't
like-
matter if it actually converges. I just want to like have it do 10 steps and like figure out what our time would be.
Okay, yeah.
After we get to meeting.
Okay, sounds good. Next is the dev stuff.
Yeah. Well, so I mean, Dev doesn't really change all that much. I mean, obviously, if there's anything that you find unergonomic, let me know. The thing I've been working on is getting USB GPU to work without, or I guess this is not just USB GPU, but it get USB GPU to work without depending on the internet. So the big one is the big thing that we need to do for that is the basic regs, and like on all the different GPUs, this is totally different. Anyway, I have that down to like a little less than 1.5 megs of autogen files. I can make it smaller. So one thing you could do is you could say, okay, well, like a lot of these are shared between different versions.
Wait. So how do you get it down to 1.5?
Like it just filtered to the ones that we need using regexes, like a list of regexes.
How long is the regex list?
There's like, I don't know, it's like 10 lines or something. I have a PR open.
Yeah, I don't know. 1.5 megs probably fine.
Okay.
Let's not go crazy with some complex thing that could have bugs.
Okay. Yeah. Anyway, I think that works. I just need to run and see.
Yeah, I mean, what's our current what's our current pi package size? 1.8 megs.
Okay.
So how much are we increasing it?
1.4.
I think we keep it under 5 megs. Like let's. I mean, it'd be nice if it fit on floppy disk, but like, wait, really? That's how much space these things use?
Well, the problem is that like there's a lot. There's nowhere where it's documented like which versions of like hub that you need, where it says like, okay, like this GPU has this hub and this GPU has this version of this thing. So I'm kind of being sort of conservative in saying that we need all of them, or at least all of them within a certain range. But like, I don't have a 7800 XTX to see like, oh, what does that GPU use, or like this mobile processor that we definitely should support, but it has a different. It may have a different version of this IP version.
Nimmelgen, do you have any thoughts on this?
No, I think this approach, filter and registers is the correct one. Because,
cool.
I mean,
The other thing that I had thought about doing was saying like, okay, like let's just include the ones that we know we need for now, and then if someone complains that we can add the other ones, but it's kind of annoying.
That's annoying. Yeah. Okay, fine. 1.4 megs. We'll accept it.
Okay.
We'll accept it. Tinygrad the next, and then I think we'll do a release after that.
Okay.
The
other thing. Oh, sorry.
That's it.
The other thing that I was thinking about doing was, so we look in lib firmware now for AMD GPU firmware, but like in theory we could do the same thing for NVIDIA firmware. Like some people already have in lib firmware NVIDIA the GSP binaries. So I was considering looking at that, but right now we do this weird thing where we parse it from a C file, and rather than downloading the binary. So we download like some C file, and then that C file inside the C file has like a array literal that contains the bytes, and then we parse that.
Well, that's of the that's of the bootloader.
But when I looked, if you look in libfirmware, they have like separate binaries, and one of them says like bootloader, and one of them says.
I mean, I think NVIDIA's one is more weird because it's not included in the. Maybe they upstreamed it to Linux firmware.
I think they did.
And also, the problem for different binaries is that they can change. Like we should like the GSP structures and the binary and the bootloader, they should have all the same version. Exactly the same version.
I see. Yeah.
I mean, we should pin everything with a hash anyway if we're going to go.
Yes. Yeah. If the hash is wrong, then you have to download.
I mean, we should check that. We should check the hash anyway. Is there like some arg to fetch to like validate the hash?
Oh yeah, we should do that.
Probably add one. Like,
not a bad idea. Yeah. Anyway, that seems like since Nouveau has to boot the GPU, and so they use the thing in libfirmware as far as I can tell to boot the GPU.
Yeah, you need that booter. You don't actually need it for the 5090, but the 3090 and 4090 have it.
Anyway, I thought I might look at that. I mean, right now, considering we're downloading a C file, like obviously that's not the most efficient encoding for the.
And those files, those bootloaders are small anyway. It's just the GSP that's big.
That's true.
Yeah, I mean, the other question is then if we wanted to start like including firmware, but I don't think we do.
Yeah, I think lib firmware is probably pretty good for most people.
I mean, it's also there's a difference between like having to do the driver and then having to do the AMD ASIC regs are needed even if you have AMD GPU inserted, right?
Yeah.
I want if you have the driver inserted, it never has to go to the internet. Is that true for NVIDIA too?
I'm not sure. I have to check. I haven't been using an NVIDIA GPU with my dock. So.
We should check that. We should just be careful whenever we have to go to the internet.
For sure.
Yeah, definitely. Like, what good is being a self-contained project? If you're like, it's like, yeah, my installer is 1 meg. Oh, I download 7 gigs from the internet.
Yeah. For sure. Yeah. No, I thought maybe it would also be a good idea to. We have like some context bar that says like disallow opening devices or something. You could also have a disallow fetch or something. I don't know.
Yeah.
Make the error message more explicit that like you try to download something.
Yeah, well, I mean, disallow system fetch, but
yeah. I think that's it.
Next, George or stuff.
yeah. So I mean, you just try to remove dtype vac, and of course, this doesn't work. There's like 7 things you have to untangle before you can remove dtype vac, and I've done like 2 of them. So the first is the so first you can separate removing dtype vac from making the shapes correct. Like you can first make the shapes correct and just have it be in the shape and in dtype vac. So I'm almost there with that. I did get so now pretty much everything has shapes. There's a few things that don't have shapes, but we might be able to like remove it. I don't know. I'll have to like we probably still want none for some things, but
Yeah,
like
so we certainly want none for something, and I think some of UOP currently has like the empty tuple. It's probably wrong if you think about the broadcast rules for those.
yeah. Well, we want to also
because empty tuple means you expect it to broadcast, but when broadcasted, it works. But not
yeah.
everywhere can be broadcasted. So.
That's a good way to think about it. So I guess like you think about like device, and that's fine to broadcast, but yeah, that's a good thing to think about. I mean, I want to move broadcasting into the production rules anyway.
Yeah.
We'll get there. Hopefully this stuff. I tried to do like some refactors to move some stuff out of ops.py because like that's kind of the thing that's going to be like left on UOPS. These like production rules. These production rules for dtypes, these production rules for shapes, these production rules for devices. And these recursive production rules, but yeah, they're much better because they don't involve any like it's always my saying about buttons, right? Like you should never give the user a button, right? Because if you give the user a button, they're going to press it when you don't want them to press it, and they're not going to press it when you want them to press it. So why give them the button? And that's like what dtype is on UOP, right? Like we're giving them this option, but why? Right? Like there's the right answer. There's an obvious right answer. You shouldn't be allowed to put anything in besides the obvious right answer. So yeah, like dtype needs to be removed from UOP, and part of that is removing vac. I think I have a plan to do that slowly. But so I can get the shapes. Most of the shapes are like kind of correct now, but I haven't gotten the actual vector shapes to be correct because the big blocker on that is the image indexing. The image indexing is done with a vec2, and it shouldn't be because it's actually just normal 2D indexing. It's normal 2D indexing like we use everywhere else. It gets a little bit annoying because late indexes can have a gate. But then you realize that like late indexes just shouldn't have a gate. That gate doesn't belong on the index. That gate belongs on the store. So moving the gates to the store. And then you realize that, well, do you want to move the gates to the load? And then you start realizing, well, I don't even want load. Load is ridiculous. Like, what is load? right? Load doesn't really mean anything. What load really is a store from a global to a register, or from a local to a register. So we can make the definition of that register explicit, and that cleans up a whole bunch of things. But okay, now we're getting into this really big refactor. So I'm just going to explore rewriting Codegen, and seeing kind of where that goes. Because there's so much crap. Like if you look at that store, it doesn't have ranges anymore. I feel like there's a lot more things like that. I feel like there's a lot of things in Codegen that only exist to reference something that used to be in Codegen, and it's just a lot more complex than it needs to be. I have a prototype of just removing the expander entirely. The expander is not really anything. The expander is just a bunch of reshapes in broadcasting, basically. So we can just use reshapes in broadcasting. Yeah, so we can rewrite that with reshapes in broadcasting. You still have to have the devectorizer. This doesn't remove the devectorizer. And the devectorizer conflates basically two concerns. One of the concerns is how to destructure loads. Right, so if you have a load of like a vec9, you can't actually do that on a GPU. You have to refactor that to loads of like, if it's all contiguous, loads of like 4, 4, and 1. Or if it's not contiguous, maybe it all has to be 1 or whatever. So there's that. And then there's the devectorizer, which says, well, you can actually add a vec9 to a vec9. You have to turn that into individual adds because that's how GPUs work. So that stuff kind of basically has to stay. But the expander can go. Yeah, I mean, it's not like that messy. It is kind of clean. And then we also can do more to just drive the separation between. Right now, there's 2 stars before it, this step called add loads. But that kind of begins the like code gen section. And the earlier part is all like part of scheduling. So there's kind of like 3 steps right now in our lowering pipeline, right? There's schedule, which breaks things into kernels and does rangeify. There's like early code gen, which is what does optimizations and beam search and reduce folding and local buffers and all those things. And then there's like late code gen, which does decompositions, removing of weekend, those kind of things. Right. So it's a pretty clear 3-stage pipeline. We can just like tighten it up a bit. I'll play with it. Hopefully, E-type vec will finally be gone. Whether it's a full refactor or not. Usually, I like do these full refactors. I get halfway through them, and then I'm like, I could just clean the whole thing up.
I think makes sense. Great. Anything else?
Oh.
Okay. Next is mixing. So I clean up like rent, mobile rent, rent now should be easier to read. Then you will understand that some in rent function we use bigcast, and then in bigcast function we use dibmod, and we cannot move dibmod because dibmod is different. So a very similar story of that rabbit hole. I came to the conclusion that we probably just want all the dibmod to be the floor dibmod, because actually most of the dibmod we use in actual kernel source is indexing math, and those can really be simplified better if you have the floor version, not the cdiff version.
So the floor version is the Python version, not the C version.
Yeah.
And we're using the C version now. I'm not even really sure which one we're doing.
So for now, tensor.py use the floor Python version, but ops.idiff and ops.mod is the cdiff version.
I
And that's
see.
why we have flags like correct div mod folding rules, because sometimes you can fold, sometimes you cannot. This is creating troubles, not just because the one in tensor and one in uops are different, but also just mathematically always have the floor version is better because you can simplify more. Halide specifically pick this for the same reason. And on GPU, there's no single instruction for these anyway. It's always the same correction, just off by 1 or not, if it's negative and something like that. So I think I would just do something similar.
Yeah, I have no problem with adding some more complexity to a GPU kernel that's doing integer division or something.
Especially if you know the vmin of that is always positive, you don't even need to code a more complicated version. So it might be a few D-type dependent render paths, but that's just very similar to how we Codegen LLVM. Well,
Yeah.
that's my justification. Then I start to look into how to really do this migration because this thing is everywhere.
So you want to add another UOP for
No, I don't want to add another UOP. I probably will just rename the current ones to floor first, then actually change the meaning to be floor ones.
well, but if you don't add another UOP, like how does that lowering stage work?
Which one?
The stage that, like, what if it is negative, right? You know what I mean? Like I did this.
In render?
Yeah, floor div is not renderable in C, right?
Yeah, so in render, you just render the correct version.
Oh, you want to put that in renderer. You don't want to do that earlier.
No. We will put that in render. Or I want to put that in render.
Are you sure?
So I think that's the correct place.
I
Or
really
at least at least every part that we touch symbolic and do the simplified transformation, I want it to be floor.
Oh, completely. Yeah. No, but I'm saying that I think the right place might be in something like decompositions.
Oh yeah, maybe that
Yeah.
I haven't thought through. So it's the same thing. Like, do you do this thing in decomposition so that it writes into the cdiff and c bot at the end, or you just put it as a rendered rules? I haven't thought about that.
I would definitely do it in decompositions and not as render rules. Don't worry about having multiple UOPs, right? Because like what we're getting to after, like, don't worry about this stuff once you're after like add loads. Once you're after add loads in the pipeline, we've kind of entered, like, I kind of want to merge the x86 stuff because it makes it really clear what these things are. So there's, like, after add loads, all of that stuff is basically forms of instruction selection.
Okay.
And we shouldn't put any instruction selection in the renderer. We should keep it all outside. Right? So things like this, like, don't be afraid to add more ops. They're totally fine. We just need to make sure that we really restrict those ops to only the instruction selection stuff.
Yeah.
So there's two things that are missing currently from the Codegen pipeline. One is instruction selection, and one is register allocation. But we kind of already do register allocation. We just call it memory planning. And then all of the stuff, the second half of Codegen is all basic instruction selection. And that's the full pipeline.
Okay, sounds good. Anyway, that was my next plan, and hopefully after this, everything will be cleaner. I will also look into the stack vectorize thing, other than I immediately open that function and see a .vec somewhere.
Oh, sorry. Yeah, okay, you can wait till after I get rid of that .vec. Yeah, I forgot that's still there. It's not there on my branch.
Okay.
Yeah, no, you can wait till I get rid of that.
That makes sense.
But yeah, no, I mean, I think that's a lot of the mix and stuff should be removing these methods off of UOP.
Yep.
Hey, things are finally getting simpler. Notice how we haven't really added anything in a long time. We just kind of remove things now.
I'm not too sure, but if so, that's good.
Seems like things get removed now.
Okay, let's keep that going if that's the case. And we can move on to the ones where we remove stuff, the runner refactor.
Yeah, so runners are gone now. Also clean up like the realize.py a bit. So, and it's, I think it's 99% complete. So also fixed some CI issues with RDNA for recovery. So yeah, and I started to look into the HCQ. Actually into HCQ refactor, and I started with HCQ graph. So currently I have in my branch I can render like I can render a C program to execute and use this C program to execute to execute the graph and just to push it to the GPU, ring the doorbell, and all these things.
Nice.
So I'm thinking about the USB. So actually, it currently works with Python as a backend as well, and I think a bit refactoring. So yeah, I mean, it's kind of hard. I mean, for USB, like for USB backend, I think the only solution is to use Python backend, not the CPU.
Why? I mean, what is
Because we
USB
have,
actually doing, right? Like we use libUSB, but how does libUSB actually talk to the kernel?
yeah, I think.
I mean, I'd be okay with adding ops that get rendered in C for like read and write, the syscalls.
Like really annoying on macOS though. Right?
Oh, I guess it doesn't work on Mac OS. I don't know.
Yeah.
Yeah, I mean, okay, if we use Python, like, yeah, we could have this like backdoor where you just like put like some Python code in the arg and it just execs it. Is that like what you're thinking, or?
I can do that.
No, but is that what you're
And
thinking? Like, what do you mean by use the Python backend?
no, I basically like just execute these UOPs as the Python backend. I mean,
Well, then how does that access the USB where C can't?
yeah, with the, so that's why I just, for the final solution, I think we can refactor buffer to expose the, not the memory views, but the memory IO face. So the Python backend can also use this.
Oh, I see what you're saying. Oh, yeah, no, that makes a lot of sense. Yeah, okay, that's definitely the way to do it.
Yeah. So yeah, going to work on this week.
I mean, I could also see the memory iFace kind of being exposed as like the remote protocol.
Yeah. Yeah.
But you know, I mean, I think that that's a totally reasonable approach to the USB thing. That's clean. Just have it do a Python backend and have the MIO interface.
Yeah. So because basically, like for QCOM, there is no doorbell. You just need to ioctl, and I think it's fine for C. But yeah, for USB, I think Python is the easiest solution, at least for now. I'll
So
start with this.
for the ioctl, you want to create a like ops ioctl and do that in C, or?
No, I don't know. Actually, I thought that I can refactor like the whole backends. I don't know. Actually, my idea was is that I have like the shared function and we'll just have the. Actually, I don't know. I thought that I can just. I know. I need to think about this. Yeah. Basically, I can do like a syscall with the like custom thing, but I don't know if I.
I think that's fine.
But in this, I mean, we don't have labs. I mean, I can do like like the interrupt on x86 and something similar on ARM, but do we really want this?
No, I think we can link, right? Like the elf thing can kind of link. I think there's a PR that does that.
I think the else thing currently.
No. I can, I mean, I can put like the, I don't know, at least I can like pass the pointer to the function and just call it.
Yeah, I would use like ops.custom and just call a function. I don't want to do anything that's like arch specific, like int 80 or whatever the SVC3 ARM one is or something. I do want to keep the C code architecturally independent.
But, oh, I see. Actually, I have something for barriers. For now. Like I have
Yeah.
custom implementation for x86 and ARMs.
That's probably fine. I mean, they're actually different in that. I don't know. Like if there's some like simple libc thing that extracts things like ioctl, that's good. If it like requires like thinking about like memory orderings or whatever, then I don't know. Maybe there's only x86 at ARM. Whatever you think is good. I mean, I really like this direction. I'm okay with assuming that we have a C compiler in every environment, so I wouldn't like worry about that. Right? It's kind of like the system backend, and to think that tinygrad eventually like because I think as these neural network runtimes get more complex, like think about something like what's the token when you speculative decoding. Like imagine speculative decoding being generated kind of as like a C program, right? Like the C program is the scheduler. So yeah, it's the eventual like direction that all of this stuff goes, right? Like it's just like, these things get so like it's like tricky to like think about. Okay, like this is the Python, this is the C, this is the GPU, but I think we have a clearer understanding of what these things actually are than like everybody else. Right? Like because they've built these abstractions, but these abstractions are somewhat nonsensical. Well, like HIP and stuff is somewhat nonsensical, right? Like they this is all based off an abstraction. It's like 20 years old now. Yeah, but then when you think about like where the actual trigger is, what actually has to run on the CPU, what can the GPU do to schedule itself, and all of these kind of things. So yeah, I really like this direction. Go work with the refactors. I think Realize is quite clean.
Yeah, so that's it.
Okay. Next we have Viz.
Last week I worked on tracking down the Llama kernels. And it's very good because currently with pickles, we can basically replicate everything on the null device. So merge some stuff to make the null device more like AMD. With tracing the graphs and stuff. So currently, I can work this week on tracking down the e-kernels one by one and fixing them. We're spending about 4% of step time on just copying stuff because of the custom kernel contiguousness.
Yeah, so I looked into this for like 20 minutes, and do you have a clean way to do it?
Oh, I don't think removing the contiguous from custom kernel is easy. But we can
Yeah,
probably change some stuff
I
on
I
the custom
try
kernel.
I tried removing it, and then like new contiguouses get inserted, and they're all like a little bit different.
Yeah.
So I worry that this project is just a rabbit hole, and like it looks like it's gonna like add complexity, like add a lot of complexity to gain that 4%, and then it's probably not worth it. Like if you see like some obvious wins that are simple, I think it's good. But I think trying to get rid of every last one of these it's not one bug.
Yeah, and I think to add to that, we are wrapping up the 7B MLPerf submission, and we are going to focus on the big ones right after we have a submission. So I don't know how much Viz can work on the big one now. Does it work? Something like that?
I mean, like the other direction that I wanted to go is the LLM stuff and replicating that on AMD. And I think like all these are kind of similar because they're kind of about debuggability of the scheduler and how the agents can make progress on these stuff.
Yeah, like this I like a lot better, right? If there's some way we can like expose more to the user or the agent about why those contiguouses appear. Like you kind of need them, but if you could I think the general thing here is instead of trying to fix the automatic thing, just figure out how to expose more control to the user or an LLM.
Yeah, fundamentally, like the control is more like you have to track down why a kernel got generated.
How can we help? Yeah. How can we like better expose that kind of stuff?
Yeah, that's what I've been working on.
And then also to Cheney's point, how does 405B work? Can we profile 405B?
I don't have a command to run it, so I don't know how to verify it. But it should.
I will have a command to run it this week.
Oh, it should be the same command. You just write 405B.
Oh, okay, I'll try it. I think it
Not
should work.
quite, because I need to fix some. There's the sharding stuff that has to change.
But yeah, I mean, I think basically the same project you did to get the 8B profiler down to 2 minutes. I mean, it's not just the profiler; it's down to 2 minutes now. It's also the startup time, which is down to 2 minutes, which is great. Yeah, I think we basically got to do the same thing for 405B. And I think that's more valuable than tracking down every last e copy. It's just okay. That's 4%. I mean, we have. I think like 4% is not the. I think the complexity required to address that versus like the low hanging fruitness is not worth it. I think we have other. I think there's cheaper ways to get speed gains, if that's even what we want to do. Yeah, I think in general, continuing with the overall LLM usability project, like when can we just set an LLM loose on some command and have it automatically find speed improvements?
Yep. We'll
Can
start on that.
Can an LLM remove the bank conflicts in? So if you run AMD copy matmul with whamma equals 1,
Yep.
there's bank conflict.
RJ4, yeah.
Yeah. How can we get an LLM to fix that?
That's the assembly one is a little hard because there's more problems with assembly than just Fizz.
But not just the assembly. I mean, copy matmul is not assembly.
Oh, copy matmul. I thought you were
Yeah.
talking about the assembly one.
That assembly one's crappy.
Yeah.
Yeah, no, copy matmul has the bank conflicts too. And I wonder, like, can an LLM track down the bank conflicts? Is our tooling good enough for an LLM to fix that? Like GPT-5.5 to fix that?
I'm thinking how like the Thunderkins people did it, which is like basically write a solver. So you need to like read docs and like solve it on your own. It's fun. I
Yeah.
tried a little bit with it, but like
I think that's the project, and then the 405B, just decreasing the REPL loop on 405B. We can hopefully, like, I don't know, maybe by the end of the month, or at least sometime in June, have a complete 405B run. I mean, I also want to, like, for each one of our custom kernels in Llama, I mean, we'll really see this with 405B. Like with 405B, we have to figure out which custom kernels are now not getting high MFU. Like with 405B, we should be able to get more MFU, assuming that our kernels are good. But I mean, those custom kernels like seem kind of bad. They're also in like assembly or HIP. How do we get them in our language? Yeah, like how many of the custom kernels can be rewritten in Tinygrad language? Like if you replace it with AMD copy Matmo or the flash attention one I have.
Okay. That's an open question, right? We're gonna figure that out.
We don't.
Yeah, but that's kind of like, that's kind of the project that I'm going to work on. I think it's all kind of the same project.
Yeah, it'll be interesting to see like how we can express the warp specialization stuff. And like every time I ask an LLM, it's like, oh, I can't do if, so no. But
Are the kernels warp specialized?
the AMD ones, no, but like in general.
Yeah, if the AMD
Yeah,
ones
like
aren't warp
testing
specialized, I
LLM.
wouldn't worry about it, right? Like we first want to match the AMD ones with our language. We want to replace the custom HIP kernels with Tinygrad kernels, even if they're hand-coded Tinygrad kernels, even if they're like UOP Tinygrad kernels.
Okay. Let's move on. Any open issues, especially from Kama? Kama happy?
Yeah, so I'm trying to get them to bump Tinygrad. But they're complaining about run linear NQ, the timings for enqueuing a copy at progress. And I haven't looked into this too much, but my understanding is that like, I mean, clearly we're aware of this because when we merged run linear, there we changed the assert min step time. So yeah, I mean now they're complaining about that.
Who changed the assert min step time?
Oh, it was on the edge.
Is right on the edge? Okay.
Yeah.
Okay.
Anyway, they are now complaining about that. Like we know that was something they were upset about, and that now they're upset about it. So I need to try again with I saw you merge like the faster run linear, but I that didn't make any major changes to the copy path, right? So I think that's the majority of what's being slow. Is there's a whole bunch of stuff that needs to be recomputed every time that used to be cached in the buffer X for object. Or I guess it wouldn't be buffer X for it'd be buffer copy, but I have to imagine that's where the slowdown is coming from.
Is that something you can put on benchmark?
Well,
So-
it is. It's the assert min step time.
No, but assert min step time includes a lot of other stuff.
That's true. Yeah.
Yeah, can we make
Like-
it?
Assert min step time didn't regress, no?
It did. In
Yeah, so actually in this example they have several copies and then they have one graph, and I think run linear in the recent and in master is like 4 milliseconds slower for each call, or like
Yeah.
for each exec item. Yeah.
Yeah, I mean the other thing is that like they could just like probably the right thing for them to do is to do this from blob on the tensors beforehand so that they're already on com. But it is a regression.
Sorry, which assert means step time request?
In the thing I just sent at the top of the file.
Okay. Oh, I
The
see.
driving policy ones went from 3 to 4, but yeah, it doesn't seem like major. I mean, it was only that one.
Yeah. That's the one that has 3 copies at the beginning of it.
They say. I mean, if they can use from blob instead, right? Like,
that's what I told them to do, and they're like, "Well, but now I have to write different code for AMD USB and for
fair.
Qualcomm." Which
Okay. I don't know. Do something.
yeah, I think they should use from blob. I think that's
No. But they're right about that. It should be no. That violates the Tinygrad promise. Which is write code
true,
once,
that's
run
true.
anywhere. Which is like
So,
faster, but I think
mean,
that
with some Python optimizations I know in tricks, I can probably get it down 3 milliseconds. Oh, was the current time in just?
will the C stuff fix this? I mean, that's the real solution to this, right?
Actually, no. I mean, graph is still like fast and maybe even faster than they were before. But yeah, the problem is that they have non-graphed copies.
Oh,
And that's like several calls. Yeah, and because
but
of
why
that,
don't they
like the
just
Python
graph?
overhead is.
They have to graph the copies.
I don't
They are
think
two.
there's SDMA on QCOM.
No. They have to graph the copies. Oh, if they're using ungraphed copies, then that's on them.
Wait, how do you? What do you mean?
Yeah.
No,
No,
it
they
is.
probably cannot be
QCOM
graphed
doesn't.
because it's.
Yeah, it's copying from CPU.
Oh.
I think probably.
Or like NPy.
If it's in a JIT, it's on us. If it's not in a JIT, it's on them. If it's in a JIT, then yeah, we need to like compile this to C basically. We need to compile the graph runner to C basically.
Yeah, it is in a JIT. It's doing a copy from NPy to QCOM in a JIT.
Okay. Another minor thing, we probably want to increase the granularity of assert mean step time here. Like 3 to 4 is too big.
Yeah.
I don't know if we just put like 3.5, does it work or something?
I mean, maybe we should have a different benchmark because there is a lot of noise. I don't know if increasing it
Or that we basically want to make sure that it's effectively capturing something that we don't want to regress.
Yeah.
I mean, but yeah, I think the fix here is not to is just not to go to Python for the copies, right? Like sure, we don't have an SDMA on QCOM, but we can make an SDMA out of a C thread that listens and runs mem copies, right? If we're using mem copies, we're using mem copies, but like we could have like a C thread that just like
it's frustrating that it doesn't copy at all. Right?
It's the SSDMA, the software SDMA, soft SDMA.
But it's the same memory, right?
Yeah, but this is probably copying 6 bytes. Who cares?
That's true.
It's not about the 6 bytes. It's about the 3 milliseconds of Python overhead. Oh, I'm gonna process a UOP. Gotta construct and deconstruct 252 Python objects.
Okay. Anyway, we should prioritize this and make sure it's there before our next release. Sounds good.
Yeah, I mean, I think the answer is some kind of like software SDMA thing. Imogen, does that make sense?
Yeah.
Or whatever. I mean, whatever it is, we gotta like compile it, right? Like because right now it's even though it's in the JIT, it's still running it through the realize path.
Yeah.
Okay. Anyway, I think that's it for this meeting. Thank you, everyone. I will be in San Diego next week, so see you.
See you soon.
Bye.
Bye.